And we're live. Well, welcome to Substrate Seminar. This is a bi-weekly event organized by Parity Technologies where we talk about all things substrate. My name is Sasha Lansky. I'm developer advocate for Parity Technologies. And I'm super stoked today to have Aten and Lipeng here on screen from Patract Labs that are going to be presenting about the work they're doing with Wasm smart contracts. But without further ado, I think you guys are in a better position to introduce yourselves and to tell us a bit about what you're doing. So maybe why don't we just start with that, and then we can go right into your presentation.
Yeah, thanks for inviting us, and really excited to be here. So my name is Lipeng Yue, and I'm the founder of Patract. And this is our CTO. His name is Aten. He will do the technical introduction lately. And yes, I'm mostly focusing on the product area. So for most of the design of our products and the code is all come from our CTO and the developer team.
So what kind of products are you currently working on right now?
Yeah, we have 12 lines of products all in developing. And because some of the products are already in production level, such as the Redspot and Europa, and our Jupyter testnet is online, and the Elara API services is also online for public services for end users. And right now, our projects is mostly focusing on the Explorer called Patract Scan, and our ID, Cloud ID products called Couple.
Sweet. Yeah, so I'm just sharing a link actually. I shared the link of your website, and now just shared the link with where all of your products are displayed for those that are interested in taking a look. And so, yeah, is there anything you want to also mention about the team and who both of you are before we get started?
Yeah, we started about last year, August, I think. So we are a young team and still learning a lot from Parity and Web3 Foundation and from the whole community. Our job is mostly focusing on supporting the Wasm contract ecosystem initiated by the Parity and Parity teams. So right now we are the council members of Kusama and Polkadot. So we are participating in some common issues from our community, and we are funded by the Polkadot and Kusama Treasury. So we are the infrastructure team for us ecosystem. We are not issuing a coin or launch a specific version. So we build the tools and services for our whole ecosystem and support other versions like Plasma Kala to enable Wasm contract capability and help more DApp developers to use our tools to quickly develop and Wasm dApps and run securely.
Super cool, super cool. So I'm gonna let you guys get started. I just want to mention for those watching live right now, use the question bank to ask questions. I'll be here to kind of moderate and to keep an eye on that on the troll box and the ask a question box too. And let's take it from there. I'm super excited to learn about this stuff. I hope that this can be a learning experience for others that are interested in building with the tools that Patract Labs are creating for the ecosystem, and also maybe inspired by the approach of building blockchains that are based on Wasm smart contracts. So I hope that it inspires the people watching.
Thanks. So cool. It's going to be a workshop. We will show some PowerPoints and real code. So let's welcome our CTO Aten. I will.
So cool. I'm gonna go off screen. You guys share your screen, and we'll take it from there. That's super exciting. You guys are doing a live demo and stuff.
Yeah, I will switch to switch to this guy.
Okay, thanks, Yifeng.
Hi everyone. Let me share my screen. Choose close. Okay, can you see my screen now? Cover.
I can see your screen, yeah.
Okay. This is my PPT point. Okay, if everything is okay, I will start my share today.
It's all good on my end. Yep, I think you can get going.
Okay. Hi everyone. We are the Patract Labs, and I'm the technical leader from the team. You can call me Aten. It's a great honor to share the work we have done on Wasm in the Polkadot ecosystem. But let's introduce Patract Labs briefly. Patract is a tech lab building Wasm smart contract in Polkadot. We are focusing on providing support for pilot contracts, ink, and other related techniques. As stated on our website, Patract's mission is to accelerate the smart contract industry's transition to Wasm technology stack. Polkadot is a really great platform. It provides unlimited imagination for developers and allow people to build their own chain with Substrate. Meanwhile, many business scenarios can be implemented by deploying composing contracts. So we believe Polkadot Parity chain with the contract platform will have a strong activity than other ecosystems. Parity is mainly focusing on Substrate and Polkadot's fundamental infrastructures. So there may be some missing on the Wasm smart contract part between the contract developers and between the contract developers and the platforms. There is a large gap. Our mission at Patract is to create the bridge between the gap. It has already taken 5 or 6 years to gradually build a large ecosystem for smart contract on Ethereum. Imagine a contract development who wants to build in Ethereum. He has enough toys to use. It's very easy to copy and create new contracts. While in Polkadot, a developer who wants to develop a Wasm contract doesn't have that luck. This part in Polkadot is totally blank, and that's our mission in Patract. We are here to build a multifunctional toolchain for Polkadot Wasm contract ecosystem. And look at this page. This image is from the Travel Suite website. Everyone who builds in the Ethereum knows the Truffle. We can see that Truffle Suite tools are designed around the development workflow of plan, code, build, and release, and so on. It's a loop. Therefore, Truffle, Ganache, and other products are designed around this workflow. Those products collaborate with each other and help developers around the workflow of the contract development. And therefore, for our Patract products, our Patract products also follow these design ideas. We have launched the testnet named Jupiter, this one named Jupiter, to provide a basic contract running environment, which we design the ZK Mag palette to provide some zero knowledge proof support. Then for the developer part, we work around the workflow of develop, debug, test, and deploy. And for the first project, Redspot. Redspot is a product similar to Trevor, tools to make the contract development become projectized. It covers the entire process of contract development, such as development, debug, test, and so on. Europe is a product similar to Ganesh. It's a simulation node that provides a contract running environment, and it records a lot of contract information during executing contracts. We will see Redspot and Europe later. And third, for Metis. Metis is a project similar to Open Zeppelin contracts. Its purpose is to establish a way for developers to write contract in a standard way. Yes, Metis. And next is Ask. Ask is a contract language which we are developing. It's based on assembly script. It's used for writing Wasm contract, same as Ink. But because it's based on assembly script, which is a variant of TypeScript, so it can become more popular with developers. And the next is Himalaya. Himalaya is a general name of contract SDKs in multiple languages, similar to Web3.js, Web3.j, Web3.py, and so on SDK. Currently, Polkadot.js is officially designed by Parity, but other languages do not have good support for contracts, such as Go, Wasm, Python, and .NET. And the Himalaya is for the purpose, and this project is finished 2 language SDK for Go and Python. This is from contract to the chain. And the next is chain to contract, leader. Leader is used to monitor the contract running information. For example, the storage run mechanism of the pilot contract will cause the contract to be destroyed when it doesn't have enough money. So, monitoring contract on-chain data is required. The project is currently only in planning because Ink and pilot contract can't be widely used in production environment. And the final thing for developer is Copper. Copper is our contract web IDE that integrates all our products. For example, integrates Redspot, Europe, and Ask or something else. Integrates all our products on the developer side into a service. And will provide developers with a one-stop contract development process. There is a remix in Ethereum, we all know that, but remix cannot give developer a good experience, for it doesn't have a good language service system. But remix does a good job for helping contract development. I mean, it's designed for contract. And we know that the Parity have a repo named Substrate Playground. Substrate Playground is a good use case for web IDE, but it lacks the design for contract development. Therefore, we believe that Copper will greatly help the contract development ecosystem because it's designed for the contract development and the experience can be close to the local developing. Copper is in planning now, but we expect this project to start around July. And the next thing is Elara. Elara is a product that provides blockchain endpoints for developers and users. It's similar to Infura in Ethereum. And our Elara has some unique designs, which can provide more connected node service with fewer resources. and we will introduce it later. We are rewriting this part recently, and it will be more robust in the future. And for the user side, our products mainly include the Patract Scan and the Patract Store. Among them, Patract Scan adopts a different design with other blockchain scan in the Polkadot ecosystem. Thus, it can show more detailed blockchain information. And the Patract Store will adopt a concept similar to dApps platform, which allow users to experience all kinds of dApps in one stop. And for now, it only contains several sample open source dApps. For now, Patract Scan is in development, and Patract Store is running for the first version. And the following, we will show our products. And by the way, we are building it seems I can't switch my here. And by the way, we are building the document for Wasm contract and our other products, which is named the Substrate Contract Book. The Substrate Contract Book is in this repo. Our organization repo named the Substrate Contract Book. This document can be a greatly useful tool to help developers learning and writing Wasm contract in one stop. Yes, it's a beautiful one-stop document for Substrate Wasm contract. Next, let's go through some cases and find out how does our product works. The first thing is our Redspot and Europe. Look at this. I just introduced about the Redspot is tools like Truffle, and let's build a Redspot project first. You need to make sure you have Node.js in your computer, and just type npx redspot new ERC20. And after a while, you can see there is a director named ERC20 in your directories. Then we use VS Code to open the project. Look at this project. This is not a simple contract. It's a project which contains script and test. And you could use the Redspot command to do many things like this. For example, let me type something. npx redspot help. Sorry.
I think you misspelled Redspot again.
Oh, okay. Let me try some. Here, this is the available command. This method, we use Redspot could regulate the way to organize a contract project. It has many advantages, such as this project. For example, there is a project named ELC project. This project is an ink project built by Redspot. Look at this. It's a multi-contract structure. Since the deployment of multi-project is complicated, for example, if the contractor needs to deploy the ELC first and deploy Oracle next. So if another developer wants to reproduce this project, including deploying and testing, he only needs to clone this project to local directly, keep the project structure, and use Redspot command to compile, deploy, test, and other process without spending time to study how to rebuild this multi-contract relationship. So this is the simple shoe for Redspot. And if we already have a contract, the next thing is that we need a node to run the contract. Parity has its own Canvas testnet environment for contract testing, but in the actual development of local testing process, using node to test is time-consuming and troublesome. Therefore, we design Europa to replace the node which runs the contract. Look at here. It's the Europa project. And we just type this to run the Europa in a simple way. Look at this. It's more similar to a normal substrate node, but it's not a blockchain node. I will show you later. We switch to the apps. And we can see that apps can connect it. Oops, I delete this for now. And we can see that apps can connect it to the node directly, but this block are not grow. It only has the genius block. Then we just do a simple transfer. Look at this. We can see that the extrinsics is packed immediately without need to wait the time of the block interval. This feature saves the developer a lot of time. Imagine this. If you want to do some test and you need to wait the block every 6 seconds, it will break your testing and waste you a lot of time. So use this method. You could use this Europa node. You do not need to waste time for the block interval. The feature is very important in developing and debugging, or in the combination with Redspot for integration testing, or in other cases. So Europa is a better simulation of a node environment. So when we start the Europa, we already have a node to execute the contract. Then we go back to Redspot. We already have a contract, so we need to compare it. For example, this command is to compare the Redspot. We can say that the Redspot auto-detected the ink contract in the contract dictionary directory. And this configure is from this one. We could say that the Redspot point the ink configure to point out where Redspot could find the contracts file. And the Redspot configure is could configure many things for Redspot. For example, like what we write in the document. Our document is here. we can switch to the Redspot and the configuration. Here is the configure part introduced for all configures. And after some time, we can see that the compliant target is in this directory, in the artifactories. So we already compare the contract. We all know that the apps could deploy a contract directly, so we try this first. Click this button and switch to this directory and click yes 20 contract files. And you need to enter some parameters and click deploy and sign. And after deploy, I call a transfer. It's a normal workflow for deploy and test the contract. But imagine this: if I modify something in the contract, for example, I delete this line, and then I need to recompile this contract. I need to recompile this tract again, and switch to apps, and click the button again, choose the contract, and enter the parameters again, then deploy the contract. We think this process is very troublesome and boring. So Redspot can simplify this. Look at this script, deploy script in the directory. For example, in the apps, we just do the action, first deploy a contract, and then call a function. So we can say that in this script, we also can deploy a contract, and then get a contract to do a transfer to someone with some money. To someone, I just pick some address and get the result event and print the event. Print the event. So what we just do in the apps, we can make all the actions into a script, and then we can do this command. Redspot run this script directly. We can say that the script can do the action what we do in apps. When the contract changes after compiling, we can execute this run command to quickly do the same thing. For example, if I recover the command, this line, and we recompile it again, and it will auto do the deploy and the transfer. So the Redspot cooperating with Europe will greatly free the power of contract developers. Developers do not need to switch to apps to operation the buttons, or in the normal node, he would need to wait a long time for the block to pack the transactions. And then we go to the test file. You can notice that The test provides rich tools for testing. For example, it has some expect, equal, or some helper functions. This is because Redspot testing framework is based on Mocha and char. And we have also designed our own Redspot char plugin for testing. This is the Redspot repo. Here we emphasize that Redspot is forked from the Red Hat. So the Redspot can expand its rich functions through plugins. For example, the Redspot char is a plugin, and those things are all plugins. Currently, we already have some basic plugins, and the community developers can also participate in enriching the features of Redspot. And this is Redspot. Now we switch to Europe. Look at this. During calling the contract, a lot of information is printed in Europe's log. Compare with the normal system. When execute the contract in EVM or in the pilot contract directly, the execution process of the contract is a black box for development. Therefore, Europe is committed to display the internal information of the contract execution and turn the execution process into a white box to provide the developers with rich execution information. We collected contract execution process into a nested runtime. Look at here. So for once execution, we can see the contract address and the self-address, selector, parameters, gas consumed, and other information in the contract execution. And we can notice the gas left here. When in a cross-call contract situation, I mean a contract calls another contract, only the gas consumed during the entire call can be known, but the gas consumed by each layer of the contract call cannot be known. And the gas left shows one layer's contract gas consumption. It can solve this problem. For example, in a call, contract A calls contract B. In the normal case, we only know the gas consumption for the whole process, and don't know how much gas how much gas for A and how much gas for B. And in Europe, the gas left here shows the gas consumption inside the contract, not outside, inside the contract. So we can figure out the gas consumption through the field. And next for the env trace. Env trace shows the call of host functions in this contract execution. According to these host functions, we can get more information to help user to solve the bug of contracts. And for example, we can follow the sequence of the host functions to guess where the contract is trapped. Because in contract, if a contract is trapped, then it will print a host function here. So if the contract is trapped, the following host function will not be printed. And the next field is the nest. The nest field represents the crosstalk for contract. For example, when process of the A calling B, contract A is the outlayer. Contract A is the outlayer nested runtime. And the contract B will appear in the nested part with the same nested runtime structures. It means that when contract A call contract B, and then contract B call contract C, it will all show in the nested part. Therefore, through the Europe, the execution process of the contract can be turned into a white box. It allows developers to debug the code in a better way. And in addition, Europe can also print out the Wasm backtrace when the contract trips. For example, we can add a panic in the contract. For example, we add the panic here. It's just like something right then don't expect or something else, it will cause the contract trip. And then we compile it and deploy it. Of course, if we write a panic in the construct function, when we need the contract, it will trap here. So we need the contract trapped here. And then we switch to Europe. We can say Europe has a more field named Wasm error. But this part can be puzzled to show more details. If we want to analyze this part to get why the contract is trapped, we need to install our Patract Labs version's cargo contract. We can say that this cargo contract is forked from the Parity cargo contract. But in this version, we add debug features to add more information. So we add this cargo contract now. Like this. Just wait some time and the Patract version cargo contract will be installed on my machine. Wait. Okay, it is installed. And then for these features, we need to switch to contract and do compile directly. But notice that this part is cargo contract normal command, but we add more parameters named debug in the final. This debug command just in our version cargo contract. And we compile it. Then we need to copy the new contract file to the artifacts directory, because the Redspot just recognizes these directories. And then we deploy it again, but this time we need to add no compare, no compile parameters. Oops. Scripts. Scripts deploy. And this call will also trapped here. But now we switch to the wrapper. We could see the Wasm error part. It become more details to description Wasm backtrace. For example, we can see the panic here, and we can see the new here. It's the same location in the source code because we add the panic at the new constructor. In fact, we can print the code line in the backtrace, but it's not a stable feature, so we don't show this time. Imagine this: if a contract developer he knows the Wasm backtrace, he can locate the bug quickly. So this is the workflow of Ink, collaboration of our Redspot and wrapper. After our ask could be used in production, we can add the ask configure. We can add the ask configure here. It's compiler for Ink, so we can add the ask here. For example, we divide the directory into Ink and ask. We can add the ask configure here for the spot to recognize the ask contract files, so that the Ink and the ask contracts can be developed in one project at the same time. So this is my show to the Redspot and the wrapper. This is the first workflow. So the next we will introduce the Patract data service layer. The data service layer is service for our Elara system and the Patract scan. The core of the data service is to export all on-chain data to an external database, including blocks, extrinsic, and state data, which is the most important. We can say that, in fact, we export the node on-chain data to the database. There is a project named Substrate account in Parity repo. Its purpose is to run alongside a substrate-backed chain to index all blocks, state, and extrinsic data into PostgreSQL, so we can access data from the database directly, not from the node. When we are building the data service layer in the earlier time, we used this project, but there are many problems and bugs in the project at that time. Therefore, members of our team submitted code to this project, like this one, and this one. They are all our team's members. But with the developer of our work, we believe that the substrate account no longer meets our requirements at many points. Therefore, we no longer use the substrate account as the data export component of our data service. We rewrite an account project by ourselves. It's not open source now. So based on the data service layer, we currently have 2 projects in progress, Elara and Patract Scan. Among them, Elara is a service providing node endpoints, which is similar to Infura. Its goal is to provide more nodes connection service with as less resource as possible. Some time ago, the Parity public node for apps was offline. I mean this one. The Parity public node for apps was offline, and the service for the wallet was stopped for a period of time. The endpoint available at the time was on Finality and our Elara. In that time, we used a small amount of resource to carry a large number of connecting requests, which is based on the architecture shown in this figure. In Elara system, when users access through the endpoint, they are not directly connected to node. For example, they are not directly connected to node, but connecting to our Elara middleware. Elara middleware is designed as a form that can be expanded in parallel. In this component, Elara manages connecting from the user side, including query and subscription requests. And Elara classifies the access requests according to some strategy. The subscription request from the client is hosted by Elara and subscribed by Elara middleware to the node. In this way, Elara middleware receives the state update notification of each block, node notification for each block, and notify related connection client. The query request is forwarded by Elara to the Patract data service layer instead of querying the node directly. In this way, we transfer the connection and the computer pressures from the node to Elara. Thus, Elara has a strong scalability than node. And in this way, we don't need to build a blockchain node cluster and waste a lot of resources. And next, we look at the right side. The right side is the structure of our Patract scan. All current blockchain scans basically subscribe to the events and then query the data of the chain based on the event information, then construct a data of the scan, and finally display it to users. So they need to subscribe the event and receive the notify from the node, and then query the node related data and recombine it to the business database. Well, Patract scan use directly export chain state to display data. The former is related strongly to business, while the latter is related weakly to business. We list an example. When a transfer appears on the chain, for other scans, its approaching is generally like this. First, they need to know that there is a business logic of transfer on the chain. And after the transfer occurs, an event will be printed. And they need to understand that when the transfer occurs, the balance of the sender and the receiver will change. So they subscribe to this event, and when meeting an event such as transfer, they need to query they need to query the chain for the balance of the sender and the receiver, then update the own database. We call this scan strongly related to business because it needs to make different processing according to each event. For example, transfer event needs to update the balance of the sender and the receiver, and the staking event needs to query more data related to staking. This approach is more like a poor behavior because they need to pull the data from the node. And for Patract, we do not need to deal with different situations according to the business logical of the chain, but consider how to reasonably display the on-chain state data to user. For example, for the transfer operation, the data on the chain will change according to the logical of the transfer. After the state is exported, when querying the balance of an account, we will directly display the state of the account without need to update related database table. This approach is more like a push behavior because we just query the data directly. And next, we compared our scan with apps. The apps, I mean this one. This wallet apps. The pattern of the Patract scan is actually close to the pattern of Polkadot apps, as shown in this figure. The structure of the apps is split into business and view. Then for apps, actually it's a process of recombination the on-chain state data. That is on the user side. This part is user side. Business logical and the view are combined together. Therefore, apps can directly access the chain and display the on-chain state to user. And for Patract scan, the structure is equal to that. We move the business logical of apps to the backend and combine the on-chain state in the backend. Display them in the front-end view. So the part combined business and on-chain state is called the Patract Scan API. And this API can be used in different places. At now, Patract Scan's product logical is being designed, and most of the underlying infrastructures of Scan has been completed. After the product logical design is okay, Scan will start to develop, so it will be launched soon. Patract Scan is a way to use our Patract data service layer. After the Patract Scan project is completed, we can design more data layer-based products. For example, in Ethereum ecosystem, there are lots of data analysis service for DeFi, which are the secondary development for the on-chain data. So we expect that the next product is related to GraphQL because the GraphQL is very famous in Ethereum. So that's all for our Patract data service layer and the architecture of our Elara and Patract Scan. And the third part is our ask contract language. The design of palette contract has nothing to do with the contract language. And because there are many languages that can be compiled into Wasm, so we can design contract languages that can run on palette contract based on different programming languages. Then you will ask, if we already have ink, why do we need to design a new contract DSL based on another language? Because we think different languages will have different programming paradigms. In different business scenarios, different programming paradigms may be required. We think there is no such thing that covers all business scenarios using only one language. To give a typical example, there is an inherited features in Solidity. Well, there is no inheritance in Rust. Instead, it uses trait system and combination pattern. Therefore, in different business scenarios, it's suitable to use different language system to write different contracts. So we design the ask, which developers have another options to write Wasm contracts. The overall design and the model of ask are close to ink. Let's take a look at the comparisons tables between ask and ink. First, for the base language. We all know that the ink is based on Rust. And for our ask is based on assembly script, aka AS. Somebody may do not know AS. AS is a structured variant of TypeScript. So the AS programming paradigm is close to TypeScript. And TypeScript is currently a very popular programming language with a wide range of the developers. And in some cases, it is more easy than Rust. And for the second one, how these two ink and ask add language features to the language. Ink and ask are based on the original languages and add contract features by modifying the AST in the original file. Both of those are the same. I mean the abstract syntax tree. For example, for Definity, he created a new language named Motoko. And for Libra, he created a new language named the Move. But for ink and ask, they are all based on existing language. And for the third one, how we implement the ink and ask. For the ways to modify the AST are different, which is mainly due to the different features provided by the compiler of different languages. Ink could use the macros, while ask uses the compiler plugins. This means that if you want to compile the ask contract, you need to use the completed compiling environment provided by ask. However, for ink, you can compile the ink only use the Rust compiler if you want. Though they provided the cargo contract, but if you really want to compile with the Rust compiler, you can do it. And for the next one, the design-based element. For the basic element provided by the contract language, the design of the two are the same, and both are more following the Solidity design. For example, for Ink and Ask, we all designed the storage and message and event. So it's no more things to see. And for the next one is the implementation of storage. For the storage design, since the substrate state is based on the KV state, so the Ink designed the concept of spirit layout and packed layout for the storage model. Ask has not made any special innovation here, so it can be regarded as another implementation. And the final thing is the reusable. We think in contract, the reusing code is divided into two models. First one is the cross-contract core, and the next one is reuse existing code. For the first one, Ink tries to use trait definition to define the interface, but the current implementation of this part is not good enough. And for Ask, we adapt the concept of interface, which is similar to the design of Solidity. And for the code reuse, since Ink is based on Rust, the code can only be compiled. Well, Ask can use inheritance, but Ink's current support for the reuse is very limited. Typical case is, if there is already an ERC20 contract standard implementation, like the OpenZeppelin contract library. If you want to add an issue token function to this standard contract, then in Ink, currently developers only can copy the entire contract from the source repo to local and add this function. But for Ask, it can design a way similar to Solidity inheritance, inheriting from the ERC20 contract and extending the issue token function directly. So in Ask, we can say this contract is more similar to Solidity. About all the above is the content shared by our team Patract. In summary, first, we introduced the design idea of all our products, and then we select 3 scenarios and introduced our design. So thanks for the time of all. This is what I shared with you today. We are really appreciated.
Thank you so much, Aten. That was really insightful. It was really valuable. I think a lot of us here are gonna listen back to the video and watch what you stepped us through and all those products that you stepped us through. If there's any questions, those of you watching right now, please use the ask a question box. Personally, I learned a lot, and I guess my question is, just as a very general thing, like, where do you think the most development is going to be focused on in the next little while, and how do you see all these tools being used most extensively? I mean, there's a very obvious answer to that. You know, you're really trying to set the pace for creating the tools that the Ethereum community and developers in the Ethereum community have been used to all this time, but really bringing that to the Substrate ecosystem. But I would like to hear what you have to say on that.
Yeah, so as we all know, that Solidity has several limitations. So the application on Ethereum ecosystem is very limited to several kinds of dApps, like some token and DeFi. But Wasm contract can enable the creativity from Rust and assembly script. Is more advanced than Solidity. So on the long range level, Wasm contract can enable developers to develop more complex dApps, and we can expect there will be innovation in product design of the Wasm area, the dApp area. So yeah, and because we all know Substrate is a general template, so it can support several contract models like EVM, Wasm contract, and maybe Move and maybe even Definity. So the diversity in Polkadot is very great. It can embrace all the existing ecosystem and innovate with very low cost. So if we can attract the developers in EVM by the EVM compatible partitions and transfer and attract them into the new Wasm contract area, and also innovate some, absorb some new advantages maybe from Move and Motoko, we can build a great ecosystem to let developers write new kind of dApps. We can never be expected in the EVM ecosystem, because EVM can never write such complex contracts. And we can already see some signs, because in the Parity Asia hackathon in China, we see a project called Ink Bridge. It writes BTC Bridge directly by Ink. So because EVM lacks some basic libraries for the crypto libraries and can't store that kind of storage or logic, so EVM can never write a light client bridge in Ethereum. But Ink and Substrate can enable this kind of innovation. Mm-hmm. Yes. So we can expect Wasm contract to be more with high speed and high complexity and more innovation.
Fantastic. Yeah, so I'm again, I'm really excited to kind of get back and look at your docs. I recommend that those watching does the same, because I think there's a lot of valuable resources that were also shared in the chat. I guess my question is, so what do you recommend developers that are really interested in getting started with the tooling that you are developing? What's the best kind of path forward for them to get started and to learn and to kind of get their hands dirty on the tools?
Yes, first there are many testnets out there, and they can build their own testnet. So they can write Ink contracts right now. With the most important tools from our side is the Redspot and Europa. And there are some issues in the pilot contracts, the contract model and Ink. So they may give some feedback to the Parity team and to us about the experience of our products. And maybe if they can have some connection with the Parity teams, they can collaborate with them to build their dApps on such partitions, such as the Akala Plus literature you can see from our open platform website. and maybe they can start to design their own dApps, the product logic, because they can think about some ideas that can get the real advantage of the Wasm virtual machine. It's not you don't need to copy and translate the existing dApps in Ethereum. You can do some real innovations.
Mm-hmm. Cool. And we are really talking about really leveraging Wasm as a technology, and it is relatively new in the web ecosystem in general. What do you have to say on Wasm and as developers, making the most of Wasm? Where are we at currently with making the most of Wasm, and what's the future looking like?
Yeah, Wasm contract is only a direction. We are only when we set out about this concept, we only mean the virtual machine layer. But on the upper layer is the contract model design. Right now, it's the pilot contracts developed by Parity, and the language layer of Ink and Ask. But they are it's not limited. It's not fixed technology yet. We can also do some innovation in this contract model layer and the language layer. If you see the EVM compatible pattern area, you can see Parity developed the frontier and Alcala developed their own EVM compatible solutions, and maybe Plasm and Moonbeam are also audited something to meet their own unique features on their pattern. This thing will also occur for the pilot contracts model, like the Fala. They are doing the TE privacy contract, so they modify the pilot contracts to remove the rent design and maybe the storage design and the economic design to fit their needs. So I recommend our slogan is to provide solutions for the whole ecosystem. So we know we have so many parations in our ecosystem. Their need is not the same, and they also have the ability to modify and customize pilot contracts from Parity, and we can agree on a standard shared layer, but leaves the innovation area to the Parity teams. Yeah, and in this direction, and we will help. So yeah, for the Parity teams and dev teams, welcome to connect us, to contact with us, and we can see what we will do together.
Yeah, fantastic. I encourage everyone again to check out Patract Labs and contact them directly. I mean, Yipeng and Aten are here. They're real people. And I think their mission is to help developers build meaningful and creative solutions for the ecosystem. So with that, I think I kind of, I don't have any more questions. I think this was a really great live stream, and hopefully a great resource going forward for people, interested in this area of developing with Substrate. Is there anything you guys want to kind of leave us for the community with some last words before we sign off here?
We are still a very young team, so please give us more time to grow up. And we are very happy if you can give us some feedback of our tools, and because we are not alone, and we need to grow. We need to build on the Parity team works, and so we can also take your feedback to Parity and to help the pilot contracts and ink to go into mature, and we can all work together to form a stronger ecosystem. Maybe someday we will defeat EVM, because we all know EVM is not going to be fixed in the future, and we all know from the bottom technology, Wasm is way better than EVM. So let's work together to make the future happen. Thank you.
Cool. Thank you guys so much for taking the time here and making such a great presentation. I really appreciate it. And let's stay in touch. I'm super excited for the future with all this stuff. With that, I think it's a wrap. Have a great evening out there. Bye bye.
Yeah. Oh yeah. Okay. We will summarize.